Hi folks, in this lecture we're going to be looking at the logarithm functions. And we want to begin by reminding ourselves what the exponential function looks like. So if we think about a very basic exponential function, like y is equal to 2 to the x, and we consider its graph, okay, we go through that point 0, 1, get very big here, and we approach 0 here. So the negative x-axis is an asymptote. The domain of this function is all real numbers, and the range is y greater than 0. Now let's suppose we want to talk about the inverse of this function. Okay, to get the inverse we switch the x and y. So the inverse is going to be called x is equal to 2 to the y. And to get the graph of the inverse, we simply take this function and flip it over the line y equals x. And if we do that, this point, which was 0, 1, becomes 1, 0, and the graph is going to look like this. So in this case, the negative y-axis is an asymptote. The domain of this function is x is greater than 0, and the range of this function is all reals. So now, let's look at x equals 2 to the y. And what we want to do is solve it for y. And the problem that presents itself here is there's no algebraic technique that will enable us to take this expression and solve it or isolate y. And so when presented with that problem, what mathematicians do is just invent some new terminology. And so we say that if x is equal to 2 to the y, that's exactly the same thing as saying y equals, and here it is, log base 2 of x. And it's important to make sure that you say that right and write it correctly. So again, the way we say this is log base 2, notice how it's written a little bit below, of x. And it means exactly the same thing as x is equal to 2 to the y. So here is an exponential expression, and here is the equivalent logarithmic expression. And if you can understand this relationship, you've got logs pretty much knocked. So the idea that we want to make sure that you get is that every exponential expression can be written as a logarithmic expression, and every logarithmic expression can be written as an exponential expression. So here are some examples. Suppose I write this statement that m cubed is equal to 12, and I want to express that as a logarithmic expression. It's going to be log base m of 12 is equal to 3. So let's make sure we get the relationship here. This expression, this exponential expression, has a base, it has an exponent, and it has a result. When we look at the logarithmic expression, log base m, here's the base, of 12, that's the result, equals 3, and 3 is the exponent. So sometimes you may hear a teacher saying that really essentially logs are exponents, which means that when you look at this expression, this piece of it, which is what the log base m of 12 equals, is the exponent. Okay, let's look at another example. Suppose we say that log base 4 of x is equal to y, and we want to write that as an exponential statement. So Here's my base, here's my exponent, here's my result. So when I translate that, that becomes the base to the exponent equals the result. So make sure that you understand this particular screen very well. If you understand exponents, you can understand logarithms. So let's look at what it means to simplify or evaluate a logarithm. So here is a logarithm expression. Log base 2 of 8. And we want to know what that means. So the important thing to get here is this. This represents the exponent, right? Logs are exponents. This represents the exponent we put on the base, which in this case, right, is 2, to get 8. And so really what this is asking is, what power do I raise the number 2 to get 8? And hopefully what you get is that log base 2 of 8 is equal to 3, because 2 to the 3 is equal to 8. Get it? Remember again, here's my logarithm expression, and here's my equivalent exponential expression. So let's look at one more. Suppose we ask ourselves, what is log base 5 of 1 over 25? Okay, so what we're asking here is, what power do I raise 5 to get 1 over 25? And if you think about that and you remember your rules of exponents, you're going to get minus 2. And that's because 5 to the minus 2, which means 1 over 5 squared, is equal to 1 over 25. Okay? Let's do a little bit more. So here we look at what it means to solve a logarithmic equation. And here's a very simple one. Let's see if we can get it up here. Log base 5 of x is equal to minus 1. And usually the best way to solve these is to express it as an exponential expression. And so if we do that, this means, take a second, press pause, make sure you get it. 5 to the minus 1 is equal to x, which therefore means that x is equal to 1/5. Okay, let's try another one. How about log base x of 16 is equal to 2? Okay, if we translate that, we get x squared is equal to 16. And what are the possible values of x? Well, in this case, we know that x is equal to plus 4 or minus 4. But you might remember that when we talk about logs, we usually insist that the base is a positive number, so we usually would exclude minus 4 there. And there you go. So those are the different things that we do with log expressions. We want to make sure that we know what the graph looks like. We want to make sure we know how to simplify. And finally, we want to know how to solve equations. And so this short little video handles all of those. So there you go. That's the world of logarithms. All it is the inverse of exponentials. And if you can get the exponential function, then you know the logarithmic function. There you go. See you next time.